All right, so far we've worked on the first set of notes, which was molar ratios. And now I want to move on to mole conversions. So this will kind of give you an example of why we need molar ratios. So if you think back to molar mass, with molar mass, we use that as an equality to convert between grams and moles of a particular substance. Mole to mole conversions are going from moles of one chemical species to moles of another in the same equation. So let's take a look at this problem and we'll see how that goes. So how many moles of magnesium phosphate would be produced from 0.56 moles of magnesium sulfate? So when I look at a problem like this, the first thing I always do is I underline the information that's given to me in the problem. So in this case, we've got moles of magnesium sulfate is what's given to us. And I also box what I'm looking for. So it looks like I am looking for moles of magnesium phosphate is what I'm trying to get. So looking at this equation, it looks like, or this problem, we are starting with moles of magnesium sulfate and we want moles of magnesium phosphate. So we're going to need a couple of things. We're going to need to know the full balanced chemical equation, which is right here. So we have that, so that's great. And we're going to need an equality to help us get from one to the other. So in this case, it seems like we're going to be using molar ratios, shockingly, because molar ratios allow us to go from moles of one chemical substance, so in this case, magnesium sulfate, to moles of magnesium phosphate within the same equation. So I'm going to set up my skeleton, and we're going to start with the information from the problem. Okay. So moles of magnesium sulfate. The next thing that I need is I'm going to need an equality. Always goes here. In this case, it's going to be a molar ratio. So I got to figure out what molar ratio to put in here. Going back to the problem, it looks like I'm going to need the connection between magnesium phosphate and magnesium sulfate. So looking up here, that looks like it's a 3-to-1 reaction or 3-to-1 ratio. So I'm going to write out the molar ratio off to the side here. So for every 3 moles of magnesium sulfate, you can form 1 mole of magnesium phosphate. Or another way to put that, I'll put it up here. For every 1 mole of magnesium phosphate, you're going to require 3 moles of magnesium sulfate. Okay. So those are my 2 equalities. I have to now decide which one of these 2 fits best in this equation. Well, I need to get rid of magnesium sulfate and replace it with magnesium phosphate. So it looks like this is going to be the one that will work. All right. So I basically just took this equality and just dropped it right in. Taking a look at this, my moles of magnesium sulfate are going to cancel out. And I'll just be left with moles of magnesium phosphate, which is what I'm going for. So in terms of math, this is going to be, let's see what my calculator is. Oh, there it is. This is going to be 0.56 times 1 divided by 3. So again, this is that skeleton method to help us convert. And this kind of makes sense because what it's saying, we're trying to figure out how many moles of magnesium phosphate will be formed. And it should be 1/3, however much magnesium sulfate we started with, because it takes 3 times as much magnesium sulfate to make the same number or moles of magnesium phosphate, that 3-to-1 ratio. In terms of like a more, let's see, an analogy you might understand, it takes 3 wheels to make a tricycle. So if you want to make a tricycle, 1 tricycle requires 3 wheels. It's the same kind of idea. So to make 1 product, it requires 3 parts. And that's essentially the same idea. So 0.56 divided by times 1 divided by 3. It's going to equal 0.19 moles of magnesium phosphate. That is our answer. Okay. So that is how you can solve all these problems. It's very similar to the way that we did molar mass. Um, same basic method. So let's pop into your unit packet and we'll check out a couple problems from there. So unit packet, page 2. At this point, you should have already done page 1, just figuring out what molar ratios are. So this packet page has 3 problems on it, and the first 2 kind of give you the skeletons already laid out, which I think is kind of nice. So that way, when you get to the third set of problems, you'll kind of already have an idea of what to do. So let's look at this first example. So here is our chemical equation. We've got potassium chlorate decomposing into potassium chloride and oxygen. It's already balanced for us, which is very nice. So now let's read the questions. So how many moles of oxygen will be formed from 1.65 moles of potassium chlorate? So this is what the information we've been given, and we are trying to find moles of oxygen. So this problem is already set up for us in the skeleton format. So we start with the number from the problem, and now we just need to find the molar ratio between potassium chlorate and oxygen so that we can figure out moles of oxygen. And they've already set this up so that the moles of potassium chlorate's on the bottom and the moles of oxygen on top. And now we just have to fill in the correct numbers. So to get those numbers, once again, we're going to go up to the balanced chemical equation. So the moles of oxygen is 3 because of that 3 right there. And the moles of potassium chlorate is 2 because of this 2 right here. So it is a 3-to-2 ratio. So the math is going to be 1.65 times 3 divided by 2. And we're going to get 2.48 moles. Okay. All right, so let's take a look at the next problem using the same equation. The question now here is how many moles of potassium chlorate are needed. Okay, so that's giving us what we were trying to find, and our problem already has it set up for us. That's great. Our need to make 3.5 moles of potassium chloride. So again, the problem is asking us our kind of end product is it's a product, or our starting place is a product, but that doesn't really matter. We're just being asked to compare these 2 chemical species, potassium chlorate and potassium chloride. So we already have the potassium chloride put into the skeleton for us. That's great. Now we just need to put in the molar ratio. So kind of like up here, let's do the next step first. So we know it's going to be, we need to compare moles of potassium chlorate to potassium chloride. So the first thing we can try to do is which one's going to go on top? Well, I want chlorate on top so that way I'll put chloride, potassium chloride on bottom, and they'll cancel. So it's going to be kind of a good place to start. Because if we do this, once again, last time this canceled out. This time, this moles of potassium chloride will cancel out. And now we just need to put in the numbers. It looks like, according to this equation, they're both going to be 2s. So you could put it as a 2-to-2 ratio like that. If you would rather put it as 1-to-1, that's also fine, because 2 divided by 2 is 1. So 1/1 would also be just fine. So yeah, if you wanted to do it like this instead, that's also fine. So the math for this one is really easy. Once we have this molar ratio and understanding that there's a direct link, a 2-to-2 or 1-to-1 ratio between potassium chloride and potassium chlorate, it's just going to be the same. Divide by 1, multiply by 1. It's all simple math there. So 3.50. All right, last one in this series. Let's go ahead and do it. So how many moles of potassium chloride will be formed from 2.37 moles of potassium chlorate? So once again, similarly to the previous problem, that may be a little bit different, is we are comparing potassium chloride and potassium chlorate. This time we're starting off with moles of potassium chlorate. So we're going to put that here in this part of the equation. And now that we have that, that's the thing that we're trying to convert, the number we're trying to convert. We need to figure out how to convert it. We need some sort of equality. We're going from moles of one compound to moles of another in the same chemical equation. So we're going to use molar ratio. The molar ratio in this case is going to have to be moles of KCl on top and moles of KClO3 on bottom. That way everything will cancel. And again, it's a 2 to 2 or 1 to 1. So same thing. Oh no, lights back on. Come on. Oh. There we go. Ah, that's good. So 2.73 moles of KCl. All right. So just 1 second here. Sorry about that interruption. Okay, so those are some examples there. There is a whole rest of this page that you are definitely able to do now. I will have an answer key for some of these problems, but that's a good start anyway. If you want a couple more examples, or you want some more help, let me pop over to my YouTube page. See if I can find it. Here it is. Oh dear. All right, we'll come back to that. Something weird happened. 1 second. All right. Okay, something's going on with my YouTube. Anyway, there are some examples on YouTube that you could check out. So until then, check those out, see how you do on this molar ratio stuff, and we'll do more review and we'll move on to the next set of notes in a little bit. Good luck.